Hi everyone, welcome back to my YouTube channel. So today we are going to solve day 16 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2425. Bitwise XOR of all pairings. Okay, so let's read the problem statement first. You are given two zero indexed arrays nums1 and nums2. Okay, consisting of non-negative integers. There exists another array nums3 which contains the bitwise XOR of all pairings of integers between nums1 and nums2. Okay, every integer in nums1 is paired with every integer in nums2 exactly once. Okay, and we have to return the bitwise XOR of all integers in nums3. All right, so here what is it is saying that this 2 is going to make pair with 10 first, then 2, then 5, then 0. Okay, then this one is going to make a pair with 10 first, then 2, then 5, then 0. Then this 3 is going to make a pair with 10, 2, 5, and then 0. Okay, but see the constant size is very large. Okay, 10 raised to power 5. All right, so definitely if we run two loops, okay, to do this. Okay, first take this element and then check all the pairs, do the bitwise XOR, then take this pair, then do the bitwise XOR of all the elements, then take this 3 and do the bitwise XOR of this 3 with 10 to 5 0. Okay, so definitely our time complexity is going to be of n square. Okay, so that solution is not going to be the best for this one. Okay, for this problem. All right, because the constant size is very large. All right, so now is there any other way to solve this problem? Okay, so here first of all let me draw XOR table. Okay, how XOR table looks like. Okay, so here let's say there is one value A, one value is B. Okay, and here it is our result. Okay, so now let's say if my A is 0 and B is 0, 0 XOR 0 is going to give me 0. Okay, 1 XOR 1, it is going to give me 0. Okay, so if two values are same, always I'm going to get the result as 0. Okay, now if two values are different, so let's say if my A is 0 and my B is 1, then I will get the result as 1. Okay, or if my A is 1 and my B is 0, okay, then also I'm going to get the result as 1. Okay, so this is nothing but our XOR table. Okay, so I hope that you guys are clear. So if two values are same, we are going to get 0. All right, otherwise just 1. Okay, so this is nothing but XOR properties. Okay, so now what we need to do? Okay, so see here, if I just try to make the combinations. Okay, so 2 1 3. Okay, so first let's make the combination of 2 with the 10, then 2, then 5 and 0. Okay, so here let me do that. 2's combination with 1. Okay, uh 10. Okay, first it's 10 now. 2 combination with 10, then with 2. Okay, then with 2. All right, and then with the 5. All right, okay, and then 2's combination with 0. Okay, this is done. Okay, and then XOR of 1 combination with the 10 2 5 0. Okay, so let's do that. 1 with 10. Okay, 1 with 2. Okay, then 1 with 5, and then 1 with 0. Okay, this is done. So this is done. Now 3's combination with the 10 2 5 0. Okay, so here 3's combination with 10. All right, and then with 2. Okay, then with 5, and then with 0. Okay, so this is what we need to do. Okay, actually O of n square, it is going to give me O n square. Okay, but we are not going to do this, right? So but here I'm going to derive a property. Okay, what we need to do. Okay, so here first array, if you see, the length is 3 here. Okay, nums1 length is nums1 length is 3. Okay, and what is the length of nums2? Length of nums2 is 4. Okay, nums2 2 length is 4. Okay, so now here see here how many times this 2 is occurring. Okay, so first let's see this part. Okay, here left side 2 1 2 3 times. Okay, 2 is occurring 3 times, and here 4, 2 is occurring 4 times. Okay, all right, and here let me write 2 is occurring 4 times. All right, then see how many times 1 is occurring. 1 is occurring 1 2 3 and 4 times. 1 is occurring 4 times. Okay, and here 3 3 is occurring. I'm just considering left part right now. Okay, 3 is also considering 4 times. All right, okay, now start from the right part. So 10, so 10 is occurring 1 2 and 3 times. Okay, 10 is occurring 3 times. All right, so 10 is occurring 3 times. Okay, now this 2 1 2 and 3. Okay, 3 times. So this 2 occurs 4 times in the past. Now 3 times more. Okay, so 4 plus 3, so here I'm going to update it to 7. Okay, so 2 is occurring total 7 times. Okay, 2 is occurring 7 times, right? Okay, so this is done. Now after that 5 1 2 3, 5 is occurring 3 times. Okay, 5 is occurring 3 times. This is done. Now this 0 is occurring 1 2 and 3 times. Okay, 0 is occurring 3 times. Now anything else left? 10 we already covered, 2 we already covered, 5 we already covered. Okay, so yeah, everything covered, right? So now here 2 is occurring 7 times. Okay, so there is one XOR property that is it is commutative. Okay, so here I can write it in any order. Okay, I can write it in any order. I can write 2 7s like this, 2 2 then again 2 then again 2. Okay, so like this I can write. Okay, then write all the threes, all the ones. Okay, 1 is occurring 4 times, so write all the ones here, 1 XOR 1. Okay, then or you can write all the threes. Okay, so order is not mattered here, right? So this is commutative. Okay, this is one property of XOR. Okay, so now here if you see, if two values are same, so we are going to get the result as 0 only. Okay, if the two values are same, we are going to get the result 0 only. Okay, this is XOR property. So 2 and XOR 2. Okay, so here, okay, let me tell you one thing. So how I'm going to write 2 in binary form? 1 2 4 8. Okay, so 2 I'm going to write 2 like this now. So if I do the XOR of 2 with itself, okay, I'm doing the XOR of same number. Okay, same number. Then here 0 0 is 0, 1 1 is also 0, this is also 0, this is also 0. Okay, so output is 0, right? So 2 and 2 is going to cancel out each other, right? It is going to cancel out each other. So we have 7 twos, right? So 6 twos are going to cancel out each other. Okay, so 2 1 2 3 4 5 6, they are going to cancel out each other, they are going to cancel out each other, they are going to cancel out each other. Then only 1 2 left. Okay, in the end. So if the count of these two, okay, frequency of these two is odd, okay, then that means that just write a single 2. Okay, single 2 will be left in the end. If the frequency of this one is even, then simply write 0. Okay, then we don't need to consider. Okay, 1 is occurring 4 times, so all are going to cancel out each other, right? 3 is occurring even number time, so no need to write anything here. 10 is occurring odd number of times. Okay, so write 1 and 10 here. Okay, because 2 tens are going to cancel out each other and only 10 will be remaining. Okay, then 5 is occurring 3 times. Okay, so we need to write 5 just one time. Okay, this is done. Then zeros are occurring total 3 times. Okay, so we have to write 0 one time. Okay, so now this is the final thing that we need to do. Okay, so in O of n frequency, O of n time complexity, I'm going to find the frequencies here, and in the O of n time complexity I'm going to find the frequencies here. Okay, and then I will just check whether these frequencies are odd or even. Okay, if it is odd, then I'm going to write them one time. Okay, so now if you do the 2 XOR with the 10 XOR with 5 XOR with 0, what is the output that you are going to get? Okay, so 2, how you guys are going to write 2? You're going to write 2 like this. Okay, 1 2 4 8. How you are going to write 10? 10 you are going to write like this. Okay, so what is the output that you are going to get? 0 0 0 1 here. Okay, then 5, how you guys are going to write 5? So 5 you are going to write like this. Okay, then again if you do the XOR, so what is the result that you are going to get? You are going to get something like this. Okay, then in the end 0, so 0 how you are going to get right like this. If you do the XOR, so what you are going to get 1 0 1 1. Okay, so here this bit value is 1, this bit value is 2, this bit value is 4, this bit value is 8. So 8 plus 4 12, 12 plus 1 13. So 13 is the output. Let's see. So yes, 13 is the output. Okay, so this is what we need to do. Okay, so here simple thing, simple thing here. Now see carefully. So this you know, right? I have shown you 2 is occurring 7 times. Okay, 2 is occurring 7 times. uh, 10 is occurring 3 times. Okay, this I have written here. Okay, so now how in just off and time complexity we are going to calculate that? Okay, so what I'm going to do, so here see, first if I'm taking this 2, okay, then this 2 is going to occur, is going to make a pair with the 10 first, then this 2 is going to make a pair with this 2, then this 2 is going to make a pair with this 5, then this 2 is going to make a pair with this. Okay, so this 2 is going to make pair total 4 times. Okay, so 4 is nothing but it's going to be the length of nums2. Okay, so this is, let's say, len2. Okay, so 2 simply simple. Okay, so here what I'm going to do, I'm going to iterate over this, and in the starting frequency, okay, initially it is 0 now, so in this 0 I'm just going to add the length of this nums2 array. In this one if I move, okay, so I am here. Okay, 2 2's it is occurring for very first time. Okay, so initially the length is initially, okay, if I am starting from here, let's say, so initially the frequency of 2 is 0. Okay, so now this is going to occur very first time. So if it is occurring very first time, so I am going to take the initial frequency which is 0, and in this 0 I'm going to add the length of nums2. So I'm going to write directly 4. I'm moving to this one. Okay, 1 is occurring in the past, 1 is occurring 0 time. Okay, so now it is occurring very first time. Okay, so in this existing frequency 0, in that I'm just going to add the length of nums2. So 1 4, same way 3, and then I'm going to add the length of this nums2 which is 4. Okay, this is done, this is done. So in O of n I did this. Okay, so now I'm going to iterate over my nums2 again. So now see, this 10, it is occurring how many times here? 1 2, okay, and this is 10. Okay, and 3. Okay, so total 3 times. Okay, so here this 10, okay, it depends upon the, this 10 is going to make, if you see, this 10 is going to make combination with 2, this 10 is going to make combination with 1, this 10 is going to make combination with 3. So this 10 depends upon the length of a nums1 array, which is nothing but len1. Okay, so here 10, it is not there in my map. So 10, and here existing frequency of 10 is 0. In this 0 I'm going to add the length of nums1 array, which is nothing but 3. Okay, directly. Then I'm moving to this 2. Okay, so 2 is already existing, which is nothing but 4 times. So in this 4 I'm going to add the length of my nums1, which is 3. So 4 plus 3, it is going to become 7. All right, then 5. 5 is occurring for very first time, so 5 I'm writing 3 here, length 1. 0 occurring very first time, I'm going to write the length 3. Okay, so 2 7 1 4 3 4, 2 7 1 4 3 4, 10 3 5 3 0 3, 10 3 5 3 0 3. Okay, that's it. So in just off and time complexity I'm going to count all this. Okay, and then after that I'm just going to iterate over all these keys one by one, and then check if the frequency is odd, then just add, then just do the XOR of that particular key. Okay, one time we need to do. Okay, so this is one approach. Okay, in this approach we are using hash map. Okay, so we can actually further reduce the space complexity by not using this hash map. Okay, so first let's solve this problem using hash map. Okay, then I will give you one space optimized bit manipulation solution. Okay, after this, so first write the code for this one. All right, so this is my code part. Okay, so here what you need to do, first of all, just calculate the lengths of the arrays. Okay, so here int len1 is equal to nums1 dot length. All right, and calculate the length of 2. Okay, which is nothing but nums2 dot length. Okay, then we have to create a map to store the frequency of each number. Okay, so map of integer and here name it as frequency. Okay, new hash map. All right, so now we have to add the frequencies for nums1 element first. So each element appear here and 2 times in the final result. Okay, so length 2 times. Okay, so here what I'm going to write, you can write for just iterate over all the elements in my nums1 first. Okay, int num in nums of 1. Okay, so here frequency dot put. Okay, now what is going to be my key? My key is going to be num. All right, so now how I'm going to write the frequency of num? Okay, so first I will see that this key is existed one in my map or not. So here I'm going to write my map name, which is nothing but frequency dot get or default. Okay, so simply means, okay, this function simply means that if this key is available, okay, then get that frequency. Okay, then get that frequency of num. If it is not available, then take the default as 0. Okay, and in that we have to add nothing but length 2, okay, of nums2. Okay, that's the simple meaning. Then now same way, copy this line. Here we have to iterate over my nums2. Okay, so here frequency dot put num, and here instead of length 1 I have to write len 1 here, right? Because this is going to occur and length 1 times. Okay, so n 1 times or length 1 times. Okay, so here this is nothing but we are going to add the frequency for num2 elements, and each element appears n 1 times in the final result. Okay, that's simple meaning. Now we have to XOR numbers that appear odd number of times. Okay, so create one variable answer, initialize it with 0, right? And then just iterate over my map. Okay, int num map name dot here key set. All right, and here inside this just check if frequency dot get num. Okay, then do the modulus with 2, and if the output is 1, okay, if the remainder is 1, that simply means that this is a odd number. So now just do the XOR. Okay, answer is equal to answer XOR num. That's it, that's it. Okay, now then just return answer. Okay, so here if nums1 length is let's say n. Okay, and nums2 length is m, let's say. Okay, we are using these variables, but let's say n and m. So time complexity of n plus m, that's it. Okay, now let's run it and see if there is code issue. We'll try to fix that. So the test case has been accepted. Now let's submit it. So see, our solution is accepted, right? So now let's move to the approach 2. Okay, so we are somewhere here. Okay, so now we are moving to approach 2. Okay, so here what you need to do, the approach name is going to be space optimized. Okay, so here let me write space optimized bit manipulation solution. Okay, all right, so here what you need to do. Okay, so in this approach I'm not going to use hash map. Okay, I'm not going to use that. So how we are going to solve this problem then? Okay, without using hash map. So from here we already know that, if you see carefully. Okay, so here if the length of this nums2, okay, if it is odd, okay, if it is odd, so okay, first let's see this. If the length of my nums1, okay, this is odd, this is odd. Okay, if length of nums1 is odd, then we have to simply do the XOR of all the nums2 element. Okay, why? So here in the end, if you see, we are doing the XOR of 2 10 5 0, and these are the elements of this one only, right? If you see carefully, if the length of my nums1 is odd, then just do the XOR of all the numbers of nums2 and simply return the result. Okay, because if I am going to write this 10, okay, so it is going to occur n one times, okay, or length one times, right? 3, so definitely it is going to be make a odd number. Okay, so here 2 is forming a combination with these three, so definitely it is going to make odd number. This 5 is going to make a combination with these three, so definitely it is going to make a odd number. Okay, this 0 is going to make a combination with 3, definitely it's going to form. But here this 2 is for occurring 4 times, definitely it is going to be even. Okay, 4 times 1 is occurring 4 times. Okay, 1 is going to form a combination with 10 2 5 0. So here, if the length of my nums1 is odd, do the XOR of all the numbers in nums2. Okay, one thing. Second thing, if my nums2 is odd, okay, if the length of nums2, okay, len1 len2, okay, if this is uh, odd, okay, then just do the XOR of all the elements in nums1. Okay, these two things. Okay, and here if the frequency is even for both the nums1 and nums2, simply return 0, no issues. Okay, we are not going to check anything. So from here two things are derived. Okay, so if the frequency of nums1 is odd, do the XOR of this one. Okay, if this is odd, okay, if this is also odd, then also do the XOR of nums1. Okay, so this is the same thing that we have to do, right? So here 2 1 3 2 1 3, okay, both are odd. Now what, both are odd, so this 2 is going to form combination with this. Okay, so 2 is occurring 3 times here, 1 is also going to occur 3 times, then 3 is also going to occur 3 times. Okay, then this 2 is going to form a combination, okay, with all these. So 2 is going to form a how many times, 1 2 3. Okay, 3 is already existing one, so here it is going to form a 6. Okay, 1 is also going to form combination with 2 1 3, so it is also going to become 6. 3 is also going to form a combination, so 3 existing and 3 new, so 6. Okay, so here if you see, we are going to get the output as 0. Okay, right? But here if you do the XOR, okay, 2, or you can say simple. Okay, I'm saying that if this is odd, do the XOR of this one. Okay, so this is odd, I'm doing the XOR of this 2 1 3. Okay, if this is odd, then do the XOR of this, then also we are going to get 0. Now simply do this. So see, we are going to get 2 cancel out, cancel out, cancel out, cancel out, cancel out, we are going to get 0 only. Okay, so if, okay, so if n1 is odd, then do the XOR of nums2. If n2 is odd, then do the XOR of nums1. Okay, if both are odd, then do the XOR of all the numbers in nums1 nums2. That's it. Okay, so now let's write the code. So here let's minimize. Okay, I don't need this. Okay, that's why it's going to be space optimized now. All right, and I don't need this as well. Okay, so here create one variable, answer is equal to 0. All right, and now here if length 2, okay, if I do the modulus with 2 is equal to 1, okay, if it is odd, then just iterate over my nums array int num in. Okay, so here length 2 we are checking, so here nums2 we have to write. Okay, so nums1 we have to write. Okay, and here we are going to iterate over all the elements in nums1 and just do the XOR. Okay, answer is equal to answer XOR with a num. Okay, this is the thing we have to do. Let me just format the code. Now it looks good. Now same way here, if length 1, okay, is odd, okay, then in that case we have to iterate over nums2. Okay, then we have to do this and this, that's it. Okay, so only 18 lines of code. Okay, so now let's run it and see if the encode if we try to fix that. So the test case has been accepted, right? Now let's submit it. So we were here in the last solution. Now let's see. So see, we are here now. Okay, so I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.